Good morning, everybody. I'm sorry we had to cut the coffee break, and we all know that coffee breaks, lunches, and dinners are the most important part of every conference. However, the plenary lectures are just after coffee breaks. And now we've got a full house, so we can start. And I'm very happy to introduce the plenary speaker, which is Mario Giampietro, and he's ECREA research professor at the Institute of Environmental Science and Technology of the Autonomous University of Barcelona. Last week it was still Spain. Now you can see the speaker country is Catalonia. And well, I just returned from Barcelona yesterday, and I've got a lot of experience, and I believe long live Catalonia. So he has got very, very long CV from different institutes. He worked in Rome, Italy, Cornell University in the US, which I can very much appreciate it because I visited it earlier this year. Pennsylvania, Arizona State University, Stellenbosch Institute of Advanced Studies, which is the place I know as well, and many, many others. If I read them all, we would have very little time for the plenary lecture. And he works on integrated assessment of sustainability issues using new concept developed in complex systems theory. He developed a new scientific approach called multi-scale integrated analysis of societal and ecosystem metabolism, including biophysical and social-economic variables across multiple scales, establishing a link between metabolism of social-economic system and potential constraints of the embedding natural environment. So I believe it's more than enough from me. And Mario, now the floor is for you, open, and we've got all the time until lunch dedicated to you.
So thank you very much. I would like to thank the organizer for inviting me. It's an honor to be in such a famous and well-attended conference. I've been looking at the presentation the first day. So after that, I decided to change a little bit my presentation, which is a recipe for disaster for sure. Let's see what I would like to share with you today. I started as a chemical engineer, so I like crunching numbers. I've been crunching numbers all my life. And at a certain point of my career, I realized that crunching numbers is not enough. You have to understand what are the meaning of the numbers that you're generating, what is the purpose of the numbers that you're generating. And this is why I got into complex system theory, because there you have some epistemological complication. The numbers are stories that you are telling about the world. And then you have to be aware that even if it's a number, still is a story. So I decided to organize this presentation. Is what I learned. I'm getting old now. So what I learned as an engineer about how to make your numbers more useful. So I will start with the context. I'm now the coordinator of a very large European project, 7.8 million, so it's a lot of money. And we are trying to propose to the European Commission a new approach to the Nexus that is not about crunching numbers to tell this is better than that, but to have a check on all the process, how you decide that this is relevant indicators, how you know that your calculation is okay, and whether this should be relevant. This is what is called co-production. So the first part would be about the Nexus. What we mean with the Nexus, because everyone talks about the Nexus, is a buzzword, but nobody can define it, so the first part is about this. Then the second part is the concept of metabolic pattern of social ecological systems. That is the big picture. We tend to crunch number, but it's like if you're doing a fresco, before start painting the hands on the things, you have to start where are the castle, where are the animals, where you are in the fresco, not just focusing on generating numbers. You know, where your particular contribution in quantitative analysis belong in the big picture. And the third part is the methodology. The methodology that we developed takes a couple of weeks to be explained. So at a certain point, I decided to provide practical examples to show how does it work, what are the implications, rather than get into detailed explanation of example. That was the original plan of this presentation. Okay. So what is the new approach to the Nexus? Is that we have to have two different quality checks. One, on the pre-analytical choice of narratives. Are we discussing something relevant, or everyone share our true choice of narrative? And the second is a quality check on the formal representation, because of course the economists optimize in relation to money, the engineers optimize in relation to efficiency, the ecologists optimize in relation to the stability of ecosystem, but in reality, very often this optimization do not take in consideration the factors and the parameters that can you only see in a different narrative, in a different representation. So just start with the Nexus. Just what the Nexus is. Everyone talk about the Nexus. The Nexus for sure is a biophysical problem. No? There is if you go through different papers, is an inextricable linkage among things. We don't know how to do it. There is a force relation at different scales, whatever you do, between the use of energy and water and food. So this is the problem. But there is also another problem in another dimension. Science cannot deal with the Nexus at the moment. This is a problem. It's called a wicked problem. It's extremely difficult to model properly and solve. There are no satisfactory models of it. There are no linear interaction, and we cannot fully understand the implication for the society. So it's a scientific challenge. It's a problem that is impossible to grasp or respond to adequately from within the partial framing of individual academic disciplines. But then there is another dimension of the Nexus. Okay, this is still about scientific challenge. I mean, you can go, there are hundreds of papers now. You go for the Nexus, it's infinite. There is another major problem of the Nexus, is the problem of governance. Who take care of the Nexus? And this is not compatible with actual institution because you have a directive for the water, a directive for energy, a directive for food, but a directive do not take in consideration the other. And very often, this is what we do in magic. They are not consistent with each other. One externalize the problem to the others, no? So basically you have, if you're looking even to the European directives, non-consistent definition of policies. There is more, that the problem of governance hide a problem of politics in the sense that there are different interests beyond the choice of policy in relation to do different things. And so there are different political discussions. Is a major policy and management concept for sustainable development. Okay. Okay, so a way to try to see things all together is using, I don't know how many of you are familiar, because I understand this is an engineering more practical applied science, with the concept of semiotic process. But I mean, this is something developed in how you develop your meaning and you guide your action. It's also in cybernetic, would be the same type of problem. That you have a representation of your problem. On the basis of representation, you decide what to do. You do something, apply, and depending on what you learn, you go back, and maybe you update your representation. So basically, this semiotic process can be used to establish a link between the different aspects of the Nexus, You have a problem of governance. What are the power relations between institutions? Which are the narrative that you should use rather than other? How to restructure the organization. Then you have a problem in the external world about trying to fix demand and supply, water, energy, and food. This is a practical case. Then you have a problem in science, and it seems that one of the victims of the Nexus is the Cartesian dream that we can predict and control and optimize everything. We had this, the first day lecture, that we have to be more humble and modest, that we cannot model whatever. And then a sort of new type of science, what is now is on fashion, post-normal science, that you have to deal with uncertainty, fairness, adaptability, wisdom, rather than optimizing things. And above all, there is a political, oops, sorry, sorry. This one? This one. Yeah, no, I cannot see from here. Okay. Okay, so on the top of it, there is a political issue that is what we want to sustain in terms of sustainability, and what's volume count? We should, who is we? I mean, someone, don't tell me, I'm in Catalonia. So there is, it's not necessarily true that we is an uncontested statement. So there is this struggle for the definition of storytelling. What is the purpose? Why we are doing this? There is a discussion about what are the beliefs, the type of evidence that we use for guiding policy, and then actions, what happen in reality. Okay. So why this is the problem? Because when we are dealing with the Nexus, it is unavoidable to have people that have different purpose, people that adopt different narratives, and scientists that use different representations. So it's not easy to imagine that someone crunching number here using a certain representation is generating numbers that can be used by someone else crunching number in a different representation, a different scale. Okay. So when discussing what we do, we discuss the text of European directives, but I mean, when you are discussing on what to achieve, what has to be fixed, in reality, we are just reflecting the choice of the narrative within which the directive has been developed. And what if you are eliminating a problem within a given narrative, and by doing this, you are generating a worse problem in a different narrative with a different scale? So, this is one part coming from my complexity background. And then what is the difference between narrative and actors? So the narrative is, in general, an explanation of causality. You are identifying what is relevant. If I do this, why is this? Because of that. No, this is the explanation. So this is a very simple example of narrative about why a person is dying. Okay, we can say it doesn't have oxygen getting into the brain, or he has a lung cancer, or he was a heavy smoker, or humans must die. There are 4 narrative, 4 explanation, 4 scientific explanation, 4 evidence-based policy. They are all can be proved scientifically with statistics and things. So let's imagine who is using these narratives. A doctor in an emergency room, a pharmaceutical researcher trying to find a drug for lung cancer, a tax expert trying to reduce the consumption of smoking, or a philosopher that is reflecting about the implication of sustainability. In this case, we have 4 useful storytelling. No? The storyteller is using the right narrative to guide his action. Let's imagine that we are scrambling the actors. And we are telling to the philosopher they have to deal with lung cancer, or the pharmaceutical researcher has to use the narrative, human must die. This will be lethal for the pharmaceutical industry, and so on. So the problem here is not that the narratives are wrong, but the narratives are used by the wrong storyteller. So independently on the discussion that as engineer, as crunching number people, we have to do good numbers, there is an additional problem to be able to know which of the social actor has to use the number that we are generating, okay? Because in this case, these narratives are completely useless if they are used by the different storyteller. Second quick pill about complexity, we have a problem of scale. That is something that a lot of people crunch numbers, but nobody deal with the issue of scale. The issue of scale is very simple to show. This is the United States of America, this is Maine, and the Maine is on the East Coast. We can prove it scientifically. You can make a call from London and from Los Angeles, you triangulate, you say they are on the East Coast. Okay. Then if you go in Maine, in the Lincoln County at the coast towards south. You can make a satellite picture and you prove that it's south, scientifically proved. Then you go into Lincoln County to Pemaquid, is a village there. When I was in Cornell, I was in vacation. And then this has the coastal line toward west. You can scientifically prove 1,000 trunks where they have you can prove it. Then you have a scientific controversy because you have different evidence for the same statement. How oriented is the coastal line of either the state's county or Pemaquid? And you have a person that says, I go with the compass on the beach and I will tell you the ultimate truth. Then if you go on Polly Beach in Pemaquid with the compass, you say that the coastal line is going to north, okay? Again, you have 4 evidence that is contrasting. Why is that? Because as Mandelbrot approved, geographical objects are fractals. Depending on which scale you're observing, you see different things. It would be the same for humans. If you take a picture of you with a microscope, I will not see your face. I can take 1 million pictures. The face can only see at a different scale, no matter. It's not an issue of not having enough data. It's a different data. Okay. So if I have to call Maine and want to know what time is there, I have to use the evidence that is on the East Coast. If I want to buy a house with a porch looking at the sunset, I have to use the evidence that is the Polly Beach as the line toward north. So the choice of a scale is the choice of how to see the external wall. Then, depending on how you decide to see the wall, you get what you see. Then the most important part is to know why you have chosen how to see what you see. It seems a joke, but this is crucial, because if we don't do this, all our quantitative analysis is not particularly useful, because we will start, like up and now in sustainability science, someone say 42, no, it's 83, no, it's 55. Doesn't matter, because they are things that are not matching to each other. Their numbers are just useless. Okay. So what happened is that if I am looking to know what is the time in Maine, it is on the East Coast, or if I'm looking to know whether I can see the sunset from my porch of my room, I'm looking at a different reality. In this case, the space is a surface of the sphere. Here is a flat surface. These are what in jargon called non-reducible descriptive domain. You cannot say, I do a mathematical model here and I scale into this. No, the space here is not compatible with the definition of space there. We have to learn how to integrate non-equivalent views, not to try to have the mega model with more variables that put everything together, because it doesn't work this way. Okay. So the validity of evidence-based policy depends on the choice of storytelling. This is not scientific, so this is very important. The scientists have to be willing to debate with the other how to do better the things. This is the logic of co-production. Just to give you an example of the effect of scale, this is a test for the audience. This is the Hammer, makes 6 kilometers per liter. This is the Smart, makes 14 kilometers per liter, almost 3 times. Which one of these 2 cars is consuming more gasoline? How many of you vote for Smart? How many vote for the Hammer? You're not very democratic and no vote. Oh. Okay, guys, of course the Smart is the one, because here is the distinction between an instance of a typology of an equivalent class. When we are discussing about efficiency, you are describing the efficiency of a structural element, an instance of hammer. When you are discussing about energy is consumed by a society, is a functional element, is an equivalent class of vehicle. So the hammer got out of production because it was too expensive, and they produce, I don't know, I think less than 100,000. This is 1.6 million accounting. So this is, the more efficient you are, the more you are consuming energy. This is the famous Jevons paradox that was stated by Jevons in 1865. The more, they were saying coal, we are using too much coal because the pump in the mines are inefficient. We should be more efficient. He said, guys, the more efficient we'll be in using coal, the more coal we will use because we'll start doing other things with coal. And in fact, this would happen. Okay, this is more or less the wrap up of the first part. Why we need to do things in a different way, because otherwise we risk to generate numbers that are not useful. And this is more or less what we do in Magic. The problem is to try to have a double check on the quality of the chosen storytelling and a quality on the integrated analysis, to try to see our quantitative analysis from different perspectives, different dimensions, and different scales. And on the other hand, to check with the DG whether or not what we are doing is relevant for them, what type of problem they have, and whether or not we are helping with what we are doing to solve their problems. Okay, then this is the proposed system. You have a check on qualitative part of the perception, and you have a quantitative tools for the representation. So we started, this is an impredicative loop, but basically we start by talking with the DG about their narrative. So then we agree with them what are the things they are interested. We do quantitative storytelling. We run multi-scale simulation. We say, guys, there is a problem. This doesn't work here. This is impossible. Do you ever realize that the economy is not circular or something like that? Then you do this, and then you start recycling the things. Okay. If there are no impelling questions, we can go for the next step. Is okay so far? Okay. Next step. The metabolic pattern of social-ecological systems. This is very interesting. Like 2 weeks ago, I was in Brussels, and we were doing, discussing the new goal Horizon 2020 for the next time, and it was about the sustainability of production system in agriculture. And so we had a big piece, we had to draw on paper. He said, draw a production system. They were all high-level experts. Nobody could draw a production system, which is fascinating. We're talking about economy. Yeah. But I mean, okay, what is an economy? Can you draw what is an economy, what is made of? And if you're using the concept of metabolism, it's very easy. A metabolic like me, you have organs. So a society has different organs. Households are reproducing humans. Service and government is reproducing institution. The manufacturing is reproducing durable goods and infrastructure. Agriculture is generating food. You know, you could have different organs. They are made of functional and structural elements. They have to consume water, food, electricity, fuel, in order to be capable of reproducing themselves and reproducing the whole. So if you adopt the concept of metabolic pattern, you can define what a society is a set of functional and structural elements. They are combined in expressing an emergent property, which is reproducing themselves, and they have a double definition of identity. The society is defining the identity of the component, and the components are defining the society. It's an impredicative definition. They have to reproduce and maintain themselves, and learning how to become more adaptable. If we give this type of definition, now we can also say what is a socio-ecological system is. A socio-ecological system is the same, but this time coupled to an ecological system. So you have the technosphere, that is the part of process under human control, that is interfaced with the biosphere, which are processes outside human control, but controlled by nature. There are ecosystem, aquifer, soil, there are organs of the ecosystem. They are metabolizing as well their stuff. And the social-ecological system is an interface, is an equilibrium between what the ecosystem are metabolizing and what the society is metabolizing. Okay? Is clear? Okay. So what happened? When we had a circular economy, in the sense that the nutrients were recycled, and they were recycled not by humans, but were recycled by nature, the phosphorus, carbon, water, is natural biogeochemical cycle, recycling things. The human population was always the same. It remained for thousand years the same, okay? So what happened in this situation? In this situation, you have a size, this is the technical aspect, the funds. In the metabolic analysis, you have fund, flow, and stocks. Fund are the things that remain the same during your analysis. So the fund could be people, could be infrastructure, could be the things that remain the same. These are the size of the system. In this case, let's imagine that we say population is a fund. So the size of the population here is fund. And in ecological terms, we could do agroecosystem, would be hectares of agroecosystem. You can define what you want, but just to have one simple example. So you have 1 million people here. These people have a metabolic rate. They have flows per unit. So you could be energy per person, water per person, food per person. This is the logic of the metabolic analysis. You have a size, you have an intensive variable, flow per unit of size, and these give you a flow. So this metabolizes this amount of flow. It could be waste, how many kilos of waste per person. It could be electricity per person, how much you want. This is a way of contextualize that the flows that the society is using are not flows, are metabolized by someone for doing something. That is, if we start doing this, it would be much easier to understand things, not just energy. You don't have energy. You have electricity, not even electricity, peak electricity, base load electricity, intermittent electricity. You have different typology of electricity, no kilowatt hour. Okay. Then, if you go on the metabolic side, you have land uses, a total amount of hectares. Then you have an intensive variable, how many kilos per hectare, and you have here a flow. So at this point, the metabolism of the technosphere is compatible with the metabolism of the biosphere. These guys are getting free ride from the biogeochemical cycles. In pre-industrial time, you didn't have much of trade because, I mean, it was too expensive to carry around goods. And more or less, this was a view of the metabolic pattern of a social-ecological system. They had some compatible size between the population and the land. If you were overdoing it, too much population, Easter Island, whatever, the civilization was down because of overshooting the carrying capacity. Okay. In this situation, basically, you do not have cities because the rural people are just feeding themselves. There is a very little surplus that can go. So basically, at that time, we didn't have urban population. And this is the way there was relation. Geochemical cycles were generating agroecosystem, rural community, and very, very little surplus. You have probably a sorcerer, a chief of the village, a council, but nothing more. You do not have 70% of the workforce in the service sector. You don't have dentists, you don't have, you have a very limited amount of population in the service sector. If you were asking these people from where you get the food, they were saying from cropland. From where you get the energy, from biomass. From where you get your money, in pre-industrial time, your money is coming from your work. So basically, it was very clear. People had clear how the society works. Then something happened. You see here, we had a period of time which doubled the population from 3 billion to 6 billion in 40 years. No? In 40 years, we had how many times more increase in the population here. And what happened here? That the system started to use circular flows, it started using linear flows, fossil energy. Irrigation, pumping water out of the ground, and food produced with fertilizer, pesticide, whatever. So basically, we suspended all the circularity in order to be the technosphere going much quicker. And then we had this enormous amount of increase in population, energy consumption, whatever. So what happened? First change, we moved from rural to urban population. especially in developed countries. This is an example of developed country. The same 1 million people need much, much more grain. Not because they are eating more, but because they are using more liquids. In the developed countries, we use, for making liquor spirits, more or less the same amount of grains that we eat directly in the diet. But the vast majority goes in animal product. So we have much, much more consumption per capita. Then we are using much less land. That is surprising, but it's not surprising because we are using only good land. All marginal land is not used because it's not economically viable. So in developed country, we reduce the amount of cropland only on the very good land. And what is the trick here? That we are using stock of fossil energy. This is not renewable, but it's used for boost the speed of the system. The yield are much, much more. Like you remember, was 600 kilos, now more than 10 times. It's going to be 10 tons. It's really grains. You can produce as much as you want. Still, you, in a majority of developed country, you do not have enough production of grain for your consuming. Only United States, Canada, Argentina, Brazil are net exporter. Doesn't matter because you import a lot. So what is the big difference here compared with the previous one? Is that basically the compatibility between how much technosphere you have and how much biosphere you have is not guaranteed. We have a solution based on stock depletion. We have the solution of import. We have the overstressing of the ecosystems. And lately, we are having that this system is no longer guaranteeing a happy social fabric. In the sense, we are having problem of equity, inequity, disruption all over, immigration. The system is getting hypercycled. Some part became much richer than the other, and this is generating trouble. Okay. This is the amount of oil that Europe is importing compared with the one we are producing, just to have an idea. You have to look at this website. It's fantastic. It has all the country, the flag of the country of the world with this type of. So basically, we are importing oil. So basically, this changed dramatically the relation countryside cities. Now the oil is entering into the city, and from the city goes to the countryside. So it's exactly the opposite. The countryside are told by the city what to do. No, the city are 3% of the land, they do 97% of the GDP. So basically, the countryside completely irrelevant. No? And this is the explanation. If you are looking at the density of use of energy per land use in modern country, and you are looking at the density at which biomass is produced, you see that this order of magnitude, this is a logarithmic scale. Okay, so, and then if you are looking at where the density of the oil field, you can really understand that these things can feed these type of things. These things have a big problem in feeding these because you have to concentrate a lot of these to get to this type of density of use. Okay, so basically, this is one of the problems with circular flows. If we are serious about circulating flows and being based on biomass production, the density of biomass production, if you move biomass to biofuel, you will go much lower because you have to have the energy used to convert biomass in biofuel. It will be even lower in density when you take out the internal loop of energy for energy. Okay. So if you were asking people in the street during the Industrial Revolution, from where you get your food, they were saying from industrial agriculture. And they say, from where you get your energy? From oil wells. And then from where you get your money? From industry. So these were during the Industrial Revolution. No? And now we went into a new phase. What happened? After the starting of the peak oil and other problems, we had some what is called secular stagnation. We stopped growing the way it used to be. And so we enter in the post-truth world. The post-truth world is that no matter, we keep growing forever, doesn't matter. And even if you don't have resources, you made resources. You don't have to make, I mean, you cannot make biophysical resources, but you can make money. You can print it. Okay. So, we are now getting into a very dangerous attractor of Ponzi scheme economics. You know, how many of you know Ponzi scheme is the pyramidal scheme in which you are getting money to interest to the other? Okay. So how does it work now, the metabolic pattern of social-ecological system? Basically, we are accepting to live in a transitional state in which we are totally dependent on fossil energy. We accept to have a system that is generating growing inequity. We are accepting to have our security based on import. So Europeans are totally dependent on import of food, energy, or everything. We are looking for an increase in demand of food of 70% in the year 2050. Personally, I'm not sure from where we can produce 70% of food more than now. For sure, this will imply that Europe can no longer import all the feed that they are using because now in Europe we are basically doing animal product only, using feed from Argentina, but who cares? Nobody cares. I mean, we are, if you're looking at the preoccupation of the European Commission, this now seems to be not a preoccupation. But there are all other things that we are now running the economy with the Ponzi scheme logic. Okay, so this is the level of printing in the United States. These are trillions, so they are, look, forever they were below 1 trillion. They go to 3 trillions in 5 years, so the 3 times more printing than in the last years. Europe is going for 1.1 trillion. Now they are going down, but they've been printing a lot. But this is the most scaring part. This is the McKinsey Global Institute. They are not terrorists or extra left things. This is investment expert. So basically, starting 2007, when we had the problem with peak oil, the increase of the debt of the world was 57 trillions, more than all the GDP. This means that starting 2007, we didn't have any economic growth on this planet. We have been doing debt. Okay. What is very interesting, who is making debt? Only the rich people, because of course nobody gives money to the poor. So they are taking advantage of this Ponzi scheme are rich countries. So it's Robin Hood at the reverse, the actual situation. But there is even a worse part of the story, that if you're running a Ponzi scheme, you have to do it, give money that you get to the other, or more interest to attract more people. At a certain point, you take the money and run. What is the bad part of the story? That when the scheme is operating at this point, this is the best investment you can do. At the moment, if you have 10 million, the last things you want to do is to open a factory. You keep playing on investment fund or things, no? You don't want to do anything for real because it's more risky, more problematic, whereas in this way, until the system works, it's easy money. Okay. So what is the problem at this point? And this is concluding this second part. That if you are asking people now in the street, and they say, I mean, from where you get the food? The answer is from supermarkets. And from where you get energy? From the gas station or from the... When you get the money? From the ATM machine. There is total detachment from what is happening to the daily life of people and the biophysical roots of the economy that is beyond what we are doing. So this is a real problem that shouldn't be translated into academia. Those that are making research should not to adapt this type of thinking, trying to see through the matrix where what they are doing match into what is happening in the... So there are other things that we believe that everything can be done with innovation. And I really love this of Buzz Aldrin saying, you promised me Mars colonies, I got Facebook. Because we say, we do. Bottom line, all this fantastic innovation in practical terms, in terms the way we are using energy, the way we are eating, the way we are much less relevant than we think. Just to give you an example, Facebook, 300 billion of market capitalization, and Toyota, 150, half. Toyota has 12,700 jobs, Facebook, and Toyota 344,000 jobs. You are not giving jobs to the northern of Africa with Facebook or with Instagram, other things. So we have to a little bit look at what we are talking about when we are saying innovation, because this is an important part of the story. To have a job here, you have to have 25 million of capitalization. No, if you have to give create 300 million of jobs or something like that, really, we have to put Facebook to the galaxy and probably even further to have all the amount of user of Facebook to create a lot of jobs. Okay, so I'm doing with time?
15 minutes.
Oh, plenty of time. Okay, now, this is the original part that I wanted to present. So the way is a different approach to the metabolic part and the water, energy, food nexus. I will not get into practical example of application, but just to, in general, explain the logic, the rationale of it, because maybe it's easier to understand. So the first example is about the nexus. We have to do quantitative analysis in a different way. It is not about individual numbers using a question like Newton, F, X, F, Y. It's using patterns, handling patterns. We have a computer, we can use patterns now, not just differential equation. So an example that everyone can relate with is the diet. Everyone knows about diet? Okay, so let's imagine that we want to study the nexus, the entanglement between energy, water, and protein in our diet. Okay? So why we have this entanglement? Because when we are eating things in our diets, we have to feed different organs of our body, and then the mix of body activities requires 1,000 calories, 250 grams of water, and 56 grams of protein per person. This change, depending if you are a male, female, if you work a lot, if you are old, if you are young. So this is about the internal consumption. This quantity map in a mosaic of internal process inside the body. Okay. Then, how you get this mix? You don't get this mix by using energy, water, and protein. You will get this mix by eating different type of food. This different type of food has a mix, of energy, water, and protein, which is independent of what we want. This is what you get from food. Okay? So if you want to do a diet, you have to be capable of mixing this entanglement of flow with this requirement of entanglement of flows. So you have two systems. They are defining in independent way what are the entanglement and flow, and then you have to get how to get the two things. So we know we have the possibility of doing this type of linear programming things. You have a matrix, you can put the different things. Of course, it will never be exactly what you are looking for, because these are not mapping directly into this. But the idea here is that you are request to follow a different scale of analysis. You remember this is the coastal line of Maine, then you get the coastal line, then is the whole United States. Depending on the scale at which you are operating, you will have different way of defining the entanglement. This could be the water, energy, and food that goes into a crop field. This could be the energy, water, food that goes into a well extracting oil. And this could be then you are mixing this in the energy system, then the energy system and the other mixing together. So you have to scale up the different entanglement between energy, food, and food, energy, and water at different scales. So when preparing a diet, you cannot use models that look only at energy, only at water, only proteins. You have to start from scratch, that they are mixed at the level of the food to arrive to the level of the people. So we have to start generating system of accounting. They are dealing with entanglement of the flows at different scales. No, that the model only energy. The model is no, it doesn't go anywhere. Okay. Now, this is a second aspect, a second example. Oops. And then what happens is that if you are looking at a metabolic system, it has 4 conditions of sustainability. One has to be feasible, has to be compatible with external limit. This is something that nobody likes, especially scientists. They get money to say the limits do not exist, that we can have a new way of doing things, but unfortunately limits exist. It would be very nice to learn what are the limits. So second, you have problem of viability, internal limits determined by the process under your control. You cannot do whatever, or it'd be very expensive to do weird things. Desirability, it is compatible with our normative values and stability of institution. And then how much we accept to externalize our problem to others, because this is what we are doing at the moment, basically. A lot of things that are consumed in Europe are produced in China, or a lot of energy is produced in the Middle East. Food is produced in Argentina. So we are externalizing a lot. It's good because we can just consume, not let alone work, because the Chinese do it for us. But I mean, as consequence, not only moral, but also practical, because this can change in the future, and you don't want to be totally dependent on things happening elsewhere. Okay, so this is my example to introduce this concept. This is a 33 horsepower harvester controlled by 5 workers, operating in 1930. So this was the way of harvesting grains at that time. And at a certain point, it stopped. Do you know the story why this stops? The things didn't work because, of course, when you are for how many hours you are using an harvester in a year? A few weeks, 2 weeks, 3 weeks? Okay. For how long the horses are eating? All the rest of the year. So if you have something that you do only once a year and you need 33 horses, then you have to feed the horses for the rest of the year. No? Whereas if you have a tractor, you use the tractor, you switch off the tractor until next year you don't use it, it's okay. Okay. So let's see, this is a very interesting example of the Nexus in which the problem is in internal, is decreasing marginal return on investing in more horses. Let's see, this is the problem. Let's imagine you have 1,000 people there, and they are cultivating 2,500 hectares. Why they are cultivating this hectare? Because 400 tons are required by them for eating. 2,850 tons are required for making money, so these are sold on the market. And then you get the variable, internal variable. You need an activity of horses that depend on the amount of hectares they are using, but there is an internal loop because the horses are eating require hectares for their own eating. So the more you are increasing the amount of hectare, the more horses you need, the more hectare for the horses you need. So this is what generates a decrease in marginal return. So let's imagine that we have these 2,500 hectares of cropped land, and then we have the same example that we had before of the diet. You have on the top what the society need energy in terms of horses, they need food for eating, and they need other things for the market, the grains that are sold. These are the equivalent of the item that you are using to produce these things. What is in relational analysis called processors. So these are like production function or enzymes or whatever is what is needed to achieve a result. And then you see to have a horse, you need 1.9 hectares, 665 tons of water, and so on. So at this point, you can calculate how much water you need by looking at what type of services you need and how much water is required to produce that services. And then you could do how much land you need by looking at how much services you need and how much is the cost to generate the services. I mean, you can do this in a more sophisticated way, putting together electricity, fuel. You could have processor with more vectors. Could be much more sophisticated, but this is the basic idea. The basic idea is that you can put a relation. What are the functions that are required by the society? What are the structural elements that you are using to express this function? And what are the functional elements, the structural elements they are summing together, giving you a total requirement of? Okay. So, the metabolic pattern of a social-ecological system describes how a society is producing and using the flows of food, water, and energy to express its function. Okay. Let's see, and I'm finished with it, this is the last example, how this goes with the discussion we had before. If we get into this type of analysis, you do not have A is because of B, but you can have A depend on B and B depend on A. You can play with the different possible relations. Let's go. Feasibility is, do we have good soil? We have enough land? We have appropriate climate, enough water? Viability, if the profit is okay? Are the costs affordable? And desirability, it is acceptable according to our values? Do we like it? The point is, before starting optimizing the system or telling what should be done, how to invest, we should start to what type of problem are we dealing with? Okay. So, for instance, in this case, in the US plain, we have plenty of land, and they could get as much as market. They could sell as much as grain they wanted to the cities in the United States. The problem they had is decreasing return to scale. So what they wanted to have, tractors. You want to do innovation here, do tractors. This is the problem that they don't have. Because at a certain point, they were using 40% of the land for feeding animals. So this was meaningless. Let's imagine you have a different problem. You are in Nepal, and you have less than 0.2 hectares per capita, okay? So what they do, they have a subsistence economy, and there is no alternative to do anything else. I mean, if you are in this man with 0.2 hectares, you can do no innovation in view. You have to bring ecotourism, you can bring send fertilizer, do whatever, but if the system doesn't get some help from the outside, internally there is we can explore what can be done in the middle of nowhere on the mountain with 0.2 hectares, but I mean, rather than going for fantastic innovation would be how to integrate them with the rest of the society to do something else. This would be more reasonable. Okay. Next, you have plenty of agricultural rain, but this is a religious community, and they want to preserve their traditional knowledge. So in this case, these are Buddhist monks. They don't care about innovation. They are happy the way they are. They want to remain this way. So this is a problem of cultural constraints. Okay. Then you could have a different problem. You have less than 0.01 hectare per capita. People want to have $40,000 per capita of income, and they can do. They do financial trading, so they go on import. So this is Hong Kong. They can do it. But the point is, when we are talking about the Nexus, the technology, how to improve the situation, whatever, we have to be aware what type of problem are we dealing with? In which situation are we considering our analysis? So feasibility is you don't care about what is inside. You are just looking at what is available from fund, from nature, and what is the situation with the depletion of stocks and filling of sinks. So this is about checking the external constraints, process outside human control. Viability is assuming that you have resources and you can dispose of things, how things are getting inside your society. Of course, what is the point? That if you are looking here, energy is primary energy sources. Coal, wind, things. If you are looking here, energy is electricity, fuel, is energy carriers, is different things. You cannot have megajoule of energy. Energy doesn't exist. It's the semantic things. When you are making calculation, you have categories. Categories of primary energy sources, renewable, non-renewable, renewable, non-renewable. Then you have here categories of energy carriers. Not joule. You cannot have joules or kilowatt hour or whatever. You have to have joule of something. In money, you don't have dollars. You have dollar of profit, dollar of tax, dollar of gross revenues. You don't have dollars. No? Nobody will use dollars. I don't know why in energy people use megajoule, because it's joule. you must frame semantically what you are doing. There is a problem with desirability. If you are asking cows, they prefer to have chicken. If you're asking chicken, they prefer that we eat cows. So you are not providing an analysis which is neutral. You have to put this into account. And least but not last, there is the issue of sterilization. If you are looking at the index of environmental impact, you get the Switzerland things that are the most less impacting, more environmental friendly. All those they are making financial operations are fantastic, because they are very low in energy intensity. The problem is that in the iceberg, there is a bottom part, how much you are externalizing to the rest of the world. Of course, if you are importing everything that you're consuming and you print money, you are very dematerialized, very low energy intensity. But is this a good way? For instance, Europe, by printing money, is increasing their efficiency. We are increasing the GDP over CO2 emission. The more we print, the more efficient we become. It really depends on how we want to do this type of analysis. In relation to the missing part of the presentation, we did a massive open online course that there are 8 weeks of classes. So there are applications of this approach. So if someone is interested, go there. And this, be aware that you have to click on the bottom, because this is free, and the other, otherwise you have to pay. We have been cheated. We did the things because it was free. And then now we are being people complaining, saying, oh, this is have to pay. No, in reality, you don't have to pay, but you have to read the small letters, because if you click here, it's free, otherwise you have to pay. Another important things, we have a 300 pages deliverable done for the report, in which there is an illustration of the method and the different case studies for the application, if someone is interested. I'm really sorry that I didn't present the real applications, but I thought it was better to have the general view, how does it work, because otherwise it is very technical, the part. So if someone is interested, so I'm sorry for the last minute change, but maybe this is more the big view of the system. Is okay?
Thank you very much. We've been running few minutes into the lunch. Who is very hungry and can't survive, you are welcome to leave. But who are more hungry for the knowledge, we can get 1 or 2 questions.
Fantastic. Okay.
Since many hungry people for food in the nexus between knowledge and food.
Food wins.
Neven?
2-0.
Yes, please.
Well, I might be younger, but I'm actually quite optimistic about this change towards more non-tangible goods. If we want to decouple development growth from resources, then we have to put label of value on something that is not tangible. And you know, people like collecting things they actually don't need. How much of the resources that we are spending we actually need in the end? You know, markets say they need it, but most of the shopping you do for Christmas is of useless stuff. So why not attaching higher value to things which will be valuable to people, but will not be linked to resources? Facebook likes. You know, instead of having a big car to have a nice lady, you attract more likes and then you have a nice lady. Facebook likes are much cheaper for the environment. What do you think?
No, I fully agree with you. I mean, in the 60s, we were using half of the energy that we are using now. And I don't think that we were less happy in the 60s than I was young. Even though I'm old still, I was young in the 60s. I believe that the people in the 60s were as happy that we are, maybe even more. The problem is that, unfortunately, there are two ways of discussing our sustainability. That we have to change for real, or that we can fix it with technological fix. For instance, why we have all this problem with the alternatives? They are talking about alternatives, they are not doing particularly well, let's face it. Why? Because if you imagine that you take out fossil energy and you put alternative energy and everything else remains the same in the society, this doesn't work. This society has been developing to consume as much as possible fossil energy. Because the more you are consuming, the more you are becoming strong in technology and things. So it doesn't matter. It's not possible to say, okay, I have a society that for 100 years has learned how to consume as much as possible fossil energy. I take out fossil energy, I put alternative, and remain everything the same. We have to say, you want to have alternative energy, you have to have alternative way of consuming. I agree with you. We have to change the way we are consuming. But let's start giving this message to the population, because unfortunately, the message that you get from the European Commission, from the international whatever, is no problem. With some innovation, some technology, you can keep doing what you are doing now, and we will fix it. And personally, I don't know, but from what I see, there is no way that we can keep doing what we are doing, looking at the trend. Moreover, that every one person on this planet obviously wants to do what the Americans do with alternative things. At the moment, we don't have it. It doesn't match. And with the time we are talking, 20, 30 years, personally, I see is very, very improbable that we in 20, 30 years can capable of generating a totally different energy matrix, infrastructure, grid, whatever. So it would be wiser to start telling to the population, guys, you want to be sustainable? Let's discuss where we can change the way you are consuming energy and the type of goods and services that we are producing. I fully agree with you, but...
I think we have a boiling frog problem. If you tell the population, then they will not agree. But if you boil them slowly, it will happen. Let's see at the mobility. What happens to the mobility? If we switch to electric cars, and now it seems technically feasible, we will also switch to auto driving. So the owning of cars will be something of the past. If we are ordering cars for use, there will be only 1/4 of the cars needed. So there is much less resources being spent, but the service to the people stays the same. The only problem is that car is not anymore a status symbol for a masculine person to attract females. So we have to find other way how to attract females. And then Facebook can play that role. It seems I'm very much...
Or the electric car could be another candidate. Because in Catalonia, all the rich male I know, now I have electric car very expensive.
Maybe, but that's why we need to move to Facebook and Twitter. And I was asking my PhD students to tweet all the lectures, but it seems they don't listen to me because I'm probably younger than they are. Where are they? Sorry.
No, but you're right. There's no contest. But let me see.
Thank you very much indeed.
Thank you.
And when you go now to the lunch, you don't have to wait all in one row. You can go spread. There are many places to get food. Let's be efficient.